Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about how we find the inverse of matrix. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So to start off, what we're required to know is that the inverse of matrix is written as a to the power of minus 1, a being probably the name of the matrix, maybe it might be B or even C, but we have to include that to the power of minus 1, right, for the inverse, right? Then we also have to know that it exists if the product of the matrix and its inverse, right, is equal to I being the identity matrix. So here I've just interchanged, right? I've applied the commutative law to say A times A to the power of minus 1 is the same as A to the power of minus 1 times A, to give us A, to give us I being the identity matrix. So for the identity matrix, we've got the 2 by 2. For a 2 by 2 matrix, the identity matrix would be 1, 0, 0, 1. And then for a 3 by 3, the identity matrix would be 1, 0, 0, 0, 1, 0, then 0, 0, 1, right? So these are the identity matrices for a 2 by 2 matrix, and then for a 3 by 3 matrix, right? Then we also have to know that only square matrices can possess an inverse, right? So now let's say for a matrix A, that is equal to A, B, C, D, right? We're saying that the inverse of this matrix is given by 1 over, right? So here we cross multiply. Remember, this is D. So we say 1 over A times D, the product of the diagonals, the difference of the products of the diagonals, which is AD minus CB, right? Then multiplied by the matrix. This is now DA and then minus B minus C. So we interchange here, and then for B and C, we just change the signs. So this is the result that we get. And this, the denominator that we have here, AD minus CB, AD minus CB, this is what we call the determinant of A, and it is written as that, right? So this is the determinant of A. So now let's say we've got this example here. For this example, we're required to find the inverse of this matrix. So for the inverse, we're simply saying 1 over the determinant given by the difference of the products of the diagonals. So 3 times minus 2, right? Then minus 1 times minus 4 times the matrix. This is now minus 2, 3. Then changing the sign, this becomes positive. Changing the sign, that becomes negative. So saying 1 over minus 6 plus 4, we get a minus 2. So this is minus half. 2 minus 1, 4, 3. Let's say if this was matrix A, we're saying that the inverse is that, right? This is the inverse. And then now if we would like to check, right, to say the product of the matrix and its inverse should give us the identity matrix, we can say that this is now what? This is now minus half. 2, this is minus 2 by the way. So we're saying minus half minus 2 minus 1, 4, 3 times 3, 1 minus 4 minus 2. Right, we should get the identity matrix 1, 0, 0, 1. So we're saying 2 times 3, that's minus 6, and then plus 4 times 1. So that will be minus 6 plus 4 to give us minus 2, right? And then minus 2 times minus 4, that's 8, plus 4 times minus 2, that's minus 8. So 8 minus 8, we get a 0. And then here, minus 1 times 3, we get a minus 3. Plus 3 times 1, plus 0. And then minus 1 times minus 4, that's a 4. Plus 3 times minus 2, that's 4 minus 6 to get a minus 2. So now multiplying by the minus half, we get the identity matrix 1, 0, 0, 1, which proves that this, what we've done here, is very correct. So now we shall attempt those 3 questions, whereby we're just required to simplify the inverse for each of those. So allow me to erase this part. Okay, and maybe this as well. Alright, so for the first part, number 1, finding the inverse of the matrix 4, 1, 3, 1. We're saying 1 over the difference of the products of the diagonals, 4 times 1, which is the determinant, 4 times 1 minus 3 times 1. Right, and then times the matrix 1, 4, minus 1 minus 3. So remember, for this matrix that we put here, we interchange these A and D, like here, and then for B and C we just change the signs. So this would be equal to 4 minus 3 gives us a 1, so this would be simply 1 minus 1 minus 3, 4. Is the final result. And then for number 2, we want to find the matrix for this, the inverse for this matrix. So we're saying 1 over the determinant being 0 times 4, you get a 0, minus 2 times minus 3, right, multiplied by 4, 0, 3 minus 2. And this would give us minus 2 minus 3, that's 6. So 1 over 6, 4, 3, minus 2, 0. This is the result that we get for number 2. Then now moving on to number 3, finding the inverse for number 3. We're saying 1 over the determinant being 4 times 2 to give us an 8, minus, right, minus 1 times minus 3, multiplied by the matrix 4, 2, changing the signs, this becomes 3, that becomes 1. And then now back to this determinant, minus 1 times minus 3, we get a 3. So 8 minus 3 is 5. I'm saying 1 over 5, 2, 3, 1, 4. So this is the final matrix that we get, which is the inverse for this matrix. And then something else that we have to know is that if the determinant, if the determinant of a matrix is equal to 0, then the inverse doesn't exist. Because we are talking about a situation whereby for this determinant we now have 1 over 0 of a matrix D, A minus B minus C. 1 over 0 doesn't mean anything. So here we see that the inverse doesn't exist only if the determinant is equal to 0. So this was looking at how we find the inverse of a matrix. And please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.